angle looks something like that. My angle might not look exactly like yours. What's that point called again? A vertex. Good. All right, so that's the vertex of our angle. That's supposed to be an A. Sorry, hard to read. First thing you're going to do, first thing you should have done, take your ruler, make an arc somewhere. Or not an arc, make a ray somewhere. So I'm going to take my ruler right here. Doesn't matter where it's at. I'm making that ray. And it said in the first step of the directions to put what on this point? D. So put point D there. Is everybody to that point? Make sure you follow along. Doing what it says. Then what it tells us to do next, somebody read me the next piece of directions. So I don't have to keep looking back at my paper.
Put a point on E and draw a mark. Oh wait. Put a point of compass on A.
So you put the point and compass on A. Now, bad thing a lot of students do, they get too small. Alright? As long as it's going to touch the sides of the angles, which are these two rays right here, that's all we care about. So don't make it so small. I had a bunch of students yesterday doing something like this, putting their arc way down there. Then you can't really do anything with it, and it makes it harder. Alright? So when I put my point on A, I'm going to spread this out a little bit, and I'm going to make some arc like that. I look at John's paper, and John, don't get upset here, all right? I'm just using you as an example because I happen to see your paper. A lot of students doing this. They can't seem to stop once they start spinning this compass around. So they're making whole circles. When you make a whole circle instead of an arc, all that does is confuse you. So just make an arc. We wanted that arc to touch what? Both sides. That's it. All right. So if you make a whole circle, people get confused and go, "What? It doesn't. It comes clear out here, and this is all we want." I'm going to draw this with my pen so you can see it on the video. What does it tell us to do next with that? Does everybody see where they intersect?
Yes.
That arc touches that side right there, touches that side right there. So put a couple of big points on there. And we're labeling them what? B and C. Now don't yell this out till I ask for the answer. Think about it for a second. There's 3 different ways to name that angle. We learned them last time. So be thinking about those 3 ways, and I'm going to ask here in a second. Notice I've been walking around now. I just made that arc, didn't I? And I've been walking around, and I probably hit this a couple of times and messed it up. So if you messed it up, and we come over here and we make another arc like it says in the next part of the directions, it's not going to be right. So I'm going to go back, and I'm going to make sure that it's set at the same spot before I go back over here and make my next arc. Next set of directions says put your point on D and make an arc that goes through that ray. Something like that. So grab your compass and do that. Put your point on D. If you messed up your compass, go back over here. Put it like that so the point's back on A, and the pencil end is on the arc that you made the first time, so you get the right distance again. Then go over here, put it on D, go down through there. Looks like mine's off. What did I do? Probably just hit it wrong. Hit the point wrong, probably. Yeah, there it is. Everybody with me to that point. Now back to the angle. Somebody name that angle one way for me. Go ahead, Levi. Levi said angle BAC. Everybody agree with that? Yeah. BAC. Remembering what has to be the middle letter? That vertex, the A. All right? Give me another one, Colin. Angle A. Colin took the easy way out, right? Angle A. Remember I said I'd rather you didn't name it angle A ever, but that's acceptable answer. Third way, go ahead, Joe. Angle CAB. Joe didn't like the way Levi named it because he said BAC, so he went backwards. CAB. All three, same angle. Alright? It's like when I call Michael up here. I could call him Michael, could call him Goofball. Oops, better. I think it did ain't good for me to shut off that recording. It was a little late, wasn't it?
Let's go back and delete it.
Yeah, I don't know. I'm not that good at using them, so. What's the next part of the direction say after I draw that arc out there on that ray? This is about where probably everybody got to, right?
Use compass to find distance from B to C.
So this is probably the hardest one.
Oh, that's it.
We'll put the point on either B or C, either one. So put the point of your compass, do this right now, on B or C. I'm going to put mine on C because I can see it better. And then you move the pencil in so it's right at B. So that's about the distance. Now we're not actually measuring the distance. We're not actually measuring the distance. We're just getting the distance so that we know. All right? Last night I'm out in my backyard and I'm stepping off stuff. Do I know exactly how many feet it was when I was stepping it off? No. But do I have some idea how far, how much drainage tile and stuff I need that I'm putting in my backyard? Yeah. So that's what we're doing here. I'm not getting exact footage, inches, whatever. Then you're going to take this, you're going to come, oops, I forgot to put this point. What they say label this point? E. Somebody remind me to do stuff, I forget. So we put point E right there. It says to put this, the point of it on point E, and then you're going to make an arc. This is where Kelsey was having trouble, right? You're going to make an arc. Do I want to make an arc over here?
No.
That's never going to touch that other arc, is it? So where I want to make the arc is where it touches the other arc. So something like that. Could I have done it down here at the bottom? Yeah. Bad thing down at the bottom, mine, I didn't make my arc come out this way far enough to do it down at the bottom. I didn't make it far enough either way. So just find that spread again and make it a little longer. Like Michael said, maybe yours didn't touch up here either. Go back here, find that spread again, and make this arc longer if it needs to be longer up that way so it hits, or longer down at the bottom so that it hits. Notice where these two arcs hit, that's an intersection, right? Anytime two things cross each other, it's an intersection. I think they told us to label that intersection something, didn't they? F? Is that what they said? Then what's the last thing say?
Draw radius.
Grab your ruler. How are we going to draw ray DF? Just go from D to F. Put your ruler right there. One part on D, one part on F, and you're going to draw that ray going out through there. Name that angle for me, Michael.
FDE.
FDE. Brandon, give me another name. Michael said FDE. EDF. They left the easiest one for you, John. What's the easiest way to name that angle? Angle D. Alright, make sure anytime you're naming these angles, angle symbol out in front, so on, so on, so on. Next thing I want you to do, I know it doesn't say it on the directions, but it does say it in that little box next to it. I want you to measure those two angles. So what are you going to use to measure? This? Your protractor. Somebody hold their protractor way up in the air so everybody else in the class can see it, so that they know which one they're using. That way, huh? Just kidding, Michael. I don't think you're that. Don't be calling everybody dumb. That's not what I meant. So measure each one of those. Do that right now. Mine might not be the same as yours. Remember, if I'm measuring, you're lining up the vertex with the hole. Line up the vertex with the hole. Then you line up the black line along the bottom with one of the sides of the angle. Now, do I want to line it up this way if I was measuring mine? I guarantee if I look around the room right now, which I won't do because I'd have to make fun of you. Can I measure this angle if I line it up that way? No, the angle's not on the protractor. So I have to line it up this way. Looks like mine is about, we use this set of numbers, it's an acute angle, 50, 55, looks like about 57 degrees. I better not see Sam writing down 57 degrees on his paper because is my angle the same as his? I just drew a random angle up here. Now, is Ricky's angle the same as Caleb's way over there? Yep. All right. What'd you guys get on your angles?
32 degrees.
Somebody said 32 degrees. Anybody get something different?
31.
31. When you made it, that's on the first one. That's the one that I drew for you on your paper, right? What'd you get on the second one?
32.
Did you get the same thing on both of them? I wonder why. What's true about those two angles? They're congruent. They're exactly the same. That's what we did there. We took this angle and we just transferred it to somewhere else. The exact same angle. All right? My son, he's got this great big computer set up at our house. I wish he'd move it out to his house and get out of my house. But
Does he have a house?
that's for no.
Oh.
But he needs one. But he does architectural work. All right, he's like 24 years old. And he's got an architectural degree, so he does architectural work. He's got a computer screen that's about the size of that projector screen. Got like 6 different things up on it all at a time. Looks like Tony Stark, and you see on Avengers or whatever, Iron Man. When you see his big screen and he's got all these different things pulled up all at once and he's moving them around, that's what it looks like. This is the kind of stuff he does on there. Now on the computer, is he going to have to use these tools like we're using? No, the computer's going to, if he says copy this angle and move it over here for something, whatever he's building, then it'll do it for him. Now the bad thing is, why you're learning it this way, even though Michael doesn't want to do it, he'd rather do it the easier way. The reason you're learning it this way is if he doesn't know when he hits copy and this angle comes over here that those two angles should have both been 32 degrees, and the computer puts an angle over there and it makes it 20 degrees, if he doesn't know that they're supposed to be the same, it's going to mess up everything. All right? He just got done doing a project. It's been a while now, I guess, not just got done. He done a project over Oxford for Miami University. They're building, I think there was like 70-some new buildings over there. So it's a big project. And he had this whole big layout where a building's here, and he had to set up this building, building here, building here, building here, so on, so on, so on. There's like 70 of them, like over 20 or 30 blocks in Oxford that they're building new stuff. He messed up a couple of those buildings. What's that going to do to that whole project? Mess it all up.
No pressure.
All right, and which he did mess up, but we won't talk about that.
Oh my God.
If he'd messed it up, the way he messed it up didn't matter really. But if he'd messed it up, who's Miami University going to come back on? Not him. His company. The company he works for. Then who's the company going to jump on? Him. Now the company's just, Miami's gonna say, you know, you screwed this up, you gotta fix it, and the company will fix it. But what's the company gonna do to my son? Because this is like a multi-million-dollar project. He's done. All right? No, he didn't get fired. He did mess up, but it was something where, what did he tell me the other day? One of the buildings was off one direction by like 3 or 4 feet. Yes. 1 second. Try number 2. Go down to number 2. Try that activity. I'm going to give you a couple minutes to try it on your own. Yes. She's not here yet. Try number 2. Remember, on number 2, on the second activity, you're getting rid of B and C. Mark those out. You're going to make your own B and C. Look at Kelsey, she's such a genius. She already that far ahead.
Ours doesn't have to be the same as the outside, right?
Nope. Nope, this is a whole new thing. You're completely different. That's should be common knowledge. I'm not going to ask Daytona. Hey, Daytona, is it all right if I do this? I'm an old man. I'm going to ask. I'm going to ask my wife what I can do. Right, yeah. Which one you want? It doesn't matter if you change it from number 1 to number 2, but from number 2, doing both of them, from number 3, 2 and 3, don't change it from there. One thing I will say on this one, I'm going to draw this angle up here real quick. Again, my angle might not look exactly like the one on your paper, but we're going to go with it. That's point A, that's the vertex. If I put a point right here, is that point on the interior or exterior of that angle? Over there in that yellow box. Which one is it? What happens with that angle? Now, does it get bigger? It gets wider, but is the angle actually getting bigger? No. But is that point on the interior? Yeah. Points on the exterior would be like out here behind it somewhere, right? So when it tells you to make an arc on the interior, if I make an arc right here, is that going to be on the interior? Yeah. That's where you want your arcs to be when you make them. So don't think that, oh, I got to be real close in here, close to the vertex to be on the inside of this angle. That's not what interior means.
What are you looking like?
Right.
I just don't know.
Spectacular.
Is that right?
What's the little box say?
Alright.
Do that and that'll tell you if it's right or not.
Okay.
Do this. I know I said not to make circles, but that was for the benefit of the Good little mate. Only won't be get finished. You get finished. Read the little box out there beside activity 2 and do what it says. All right, I'm going to start doing this. Follow along. Make sure that you've done everything the way that I'm getting ready to do it. Somebody read me the first piece of directions. What did it say to do?
Put a point on A and draw an arc through both sides of the angle. Label intersection B and C.
So I draw this arc. Everybody get that far? See where it intersects the two sides? This is why we got rid of the B and C, because I wanted you to draw the B and C yourself, and I didn't want you to have to make it a certain distance there. So we got that. Somebody name this angle for me real quick before we go on to the next thing. Angle BAC. Give me another one. CAB. Angle A. What's the next piece of direction say?
Put on point B and draw an arc through the interior of the angle and don't change the
So put it on point B. All right. You could have changed it between 1 and 2. That doesn't matter. But once I put it on B and I draw my arc, then don't change it, is what it's meaning. Now, again, it says interior, so I see a lot of people yesterday trying to do this. Get it way down inside here somewhere. So it's on the inside. This is interior also. Just got to have some imagination here. Know that those angle sides go out forever and ever. If I put it on B, I make some arc out here. Look at that, John. I'm doing exactly what I told you not to do. Making big arcs for no reason. Doesn't have to be anything long, big, just something there. Then what's it say to do?
Put on point C, or put point on C and draw an arc that intersects arc from the
So we wanted it to intersect that. So am I going to start way back here and start drawing it? No, come out here close to it. All we need is where they intersect at. We don't want to draw any more than we have to with these because they're not easy to draw with, right? It's fun to sit here and spin it around and make circles, but they're not easy when you're actually trying to be precise and do something. So I have this arc, have this arc. What's it tell me to do then? Where they intersect, label point what? G. What's the next thing tell me to do? Draw a ray from A to G. Somebody want to come up and draw my ray for me? If he messes up my ray, we'll kick him out of class forever, alright?
And then use the pen or like a marker.
Yeah, use the pen, the actual board pen.
I think that big.
When I'm having Joe do stuff like this, trying to get him to see, why is Mr. Eversole struggling so much up here all the time? It's not easy, is it, Joe?
Why is this thing not working?
It's not easy, is it, Joe? Go. It's not easy, is it, Joe? So you're gonna have a new, better understanding, better love of Mr. Eversole's job, right? Somebody name this top angle for me. BAG. Name the bottom angle for me. GAC. Name the big angle for me. BAC. Name the big angle a different way. CAB. Name the big angle a third way. Ah! No!
G.
No! No! There is no other way. Why can't we name it angle A anymore? You don't know which angle you're talking about. So once we stick more than one angle in that picture, that's why I don't like using that angle A. We can't name it with one letter anymore. Is there any angle in this picture we can name with one letter? No. Not since we put that in there. What did it tell you to do? Measure all the angles, right? Anybody measure the big angle?
I do.
What'd you get for this big angle? They said 52. Anybody agree with that? 52 degrees. Anybody measure angle BAG?
I did.
What'd you get? 32?
I didn't measure that one. I didn't measure that one.
26?
Yeah.
We got more than one person agreeing with that?
Yep.
Anybody measure angle CAG?
I got
26?
Yeah.
What happened?
We split it in half.
Split it in half. What's that called in geometry?
No,
It's got a special name. We learned it last time.
is it? It's not the bisector. It is.
So this ray does what to the angle? Bisects the angle. The whole thing was 52. This part's 26. That part's 26. Anybody have questions? Come out right, John? It's amazing, isn't it? This is what I want you to do. Get out a clean sheet of paper. On that clean sheet of paper, also get out your books. Open up your books to page 44. That was the homework, right? Instead of me walking around checking the homework, this is what we're going to do. This is going to hurt a few of you. Because if you fall asleep, I'm going to let you sleep. Better do this. Big angle is RST. So we know the measure of this whole thing. Yeah, I got to change my color. So we know the measure of this whole angle right here, 114 degrees. We're looking for the measure, this is red, measure of angle RSV. Make sure you know that. That little M, when it's with the angle symbol, is red, measure angle RSV. So we're looking for that. That's going to be our answer. Measure of angle RSV equals whatever it comes out to be. How are we going to find RSV, this angle right here? 114 minus 72. You might want to have out your calculators too so you can do all this stuff. What's 114 minus 72? What is it? 42? Know this also. Oops. So you're going to write down that's your answer? No, you holler out an answer. I'm going to write it down. If it's wrong, you just made it wrong for everybody in the class that wrote it down because you said it. So make sure, get your calculators out and make sure you're giving correct answers. So that's what you should have. Problem 23. Write that down. That's our answer for that one. We're going to do that for each of these problems. Some of them you're actually going to show some work on. 25. That's the next one we're going to do. Problem 25. You don't have to draw all these, but you do have to write down the equations and show your work there on your paper. On 25, they tell us angle ABC, that's this whole angle, is 95 degrees. What's got to be true about these two smaller angles then? They got to add up to equal 95. So what equation can I set up? Be careful. Plus equals 95. Ignore that over there. So this is the equation you should set up. This expression plus this expression equals the whole angle. Is that always the way we're going to set up every one of these equations? No. That's the way it works out for this one. That's the way it's going to work out for the next one. What I want you to do on your paper there, go through and solve it. I'm not solving any of these. You're solving them. Here in about 45 seconds. When I wake up, I'm going to ask you for X. Don't give me no crap either. I know that Mrs. Brown or Mr. Harrison, whoever you had last year, did a marvelous, marvelous job of teaching you how to solve equations. Unless your name starts with a P, and Mrs. Brown says she refuses to teach people whose name starts with a P. Look at everybody looking around. Like you really believe that statement. Why are you looking around?
I just see it.
You're still looking.
Yeah, I get that. Excuse me.
Oh. I probably would have quit this job a long time ago if it wasn't for people like Michael who make me laugh because he's still looking for somebody whose name starts with a P.
Just that.
Anybody get X yet? What'd you get, Sam? 7. Anybody agree with that? Yes, no, maybe? Michael said yes because he knows Sam's smarter than him. That's the only reason he agreed with him. Anybody else get 7? All right, so we got X equals 7. Is that our answer? No. What do we got to do with that? We're trying to find, if you read the problem, it says find the measure of angle, and this is what you're going to write down for your answer along with your workout here. Measure of angle A, B, D. How are we going to find the measure of that angle? Plug in. 2 times 7 plus 23. Probably need your calculator. What's 2 times 7? 14 plus 23? 37. Everybody agree with that?
Did you ever busy looking for P?
Right.
Thank guys.
Measure of angle. What's the other angle we're looking for? Tell me what the name is. DBC. 2 different ways we could find that angle. What's one way? Could take 95 minus the 37, right? You could get it that way. That's fine. You could also plug in. If I just plug in 9 times 7 minus 5. What's 9 times 7? 63 minus 5. 58. Everybody agree with Michael? I hope so, because remember, I hear an answer yelled out. That's the answer I'm putting down. And it might be wrong. Those are the 2 answers you should have along with your work on that problem. This is the information we're given on this next one. This arrow, what's that arrow telling us? It's telling us that that expression goes with that angle. So a lot of times they'll have little arrows pointing in there because they can't fit the stuff in the picture. Somebody tell me the equation this time. 6x plus 44. Good. That's this angle, right?
Is that a negative?
Yep. Now, when we do this, it's going to be plus a negative, isn't it? So what's a better way to write that so we have less to write? Just minus. So we're just going to put minus 10x plus 65. This angle plus that angle should add up to equal the whole thing, which is how much? 117. So on your paper there, write down that equation. Write down that equation. Solve it. Turn the sheet. Here in a second, I'll ask somebody for x. Get it, Jesse? What do you do first to start to solve that? Put the x's together, right? You got 6x and negative 10x. So you got 6 x's in your pocket. You want to buy something that costs 10 x's. You got negative 4 x's. You still need 4 x's. So write down negative 4x. Then you got the 44 and the 65. Those are like terms. They're both positive, aren't they? So we just add them together. What's 44 and 65? What's that total up to? 109. So you got negative 4x plus 109 still equals 117. Negative 4x plus 109. If I work this out up here, collect like terms here, it's negative 4x. Like terms there. That one and that one, that's 109. So plus 109 equals 117. If you're not writing this down on your paper and you didn't have it, you ought to be. What's the next thing we do? Subtract 109. End up with 8 on the right side over there. The 109s cancel out. Negative 4x. Divide both sides by negative 4. X ends up equaling negative 2. Is that our answer? No. Is it alright for x to be a negative? Yeah. What's not alright to be negative? The angles or segments or anything like that, right? We can't measure something and it give us a negative. We actually can with angles, but we're not going to in here. What do I do with that negative 2 then? Plug it in. Give me one of the angles that we're looking for. Measure of angle what? XYW. Good. XYW. That's this angle right here. So I'm going to plug in right here. 6 times negative 2 plus 44. What's 6 times negative 2? Negative 12 plus 44. What is it? 32 degrees. That's one of our answers. Is it alright for that angle to be 32 degrees? Notice, even though we came out to be a negative with our x, did our angle come out to be negative? No, it came out to be positive. Name the other angle that we're trying to find. CYW. Everybody agree with that? Because I'm not even looking at it.
Yeah, I agree.
How are we going to find it?
You could either plug it in or add.
We could plug in negative 2 right there. And do negative 10 times negative 2 plus 65. Or we could just take 117 minus 32 and that should give it to us. Either way. What's negative 10 times negative 2? 20 plus 65? 85. Now we could actually check our answer, depending on which way we do it. What should these two add up to be? 117. Does 32 plus 85 add up to 117? So that tells us, hey, we must be right. Those are the two answers should have that work written down there. Any of this sinking in, Peyton? Easy stuff, you're getting bored. Just go quicker. A Raven. Peyton, why did I say Peyton? That's what it was, probably. I'm turning into Michael. Next one. We're going to write both these equations. First thing, there's a special angle in each one of these pictures. What's special about one of the angles in this picture? It's 180. Which angle is 180? Which angle is a straight angle? LMN is a straight angle. I'm going to tell you a couple things right now. Listen closely. Anytime you see this and you think, hey, that looks like a straight angle, you can assume it is. All right? That's one of the few things that you're allowed to assume in this class is if that looks like a straight angle, it is. When I draw this angle, what kind of angle is that? No, it's not. And that's one of the things you can assume in here. All right? Don't assume that that's a right angle because it looks like a right angle. We can assume that this is a straight angle. Mr. Eversole's not going to, even though I'd like to on the test, give you that angle right there and say solve for something using that and then say, ha ha, I tricked you because that angle is only 178 degrees. It's not 180. It's got a little bend to it. I'm not going to do that. If you see a straight angle and it looks like a straight angle, it is a straight angle. You see this angle? No clue what it is. Could be 90. Might be something different. How are we going to know if that is 90? It's got that little square in the corner. That's the only way. So don't assume that that is. What's the equation we're going to set up on this one? Keep going. This is where a lot of people mess up. Everybody watching right now? Do we have an equation right now? Equals 180. You got to put that in there. That confuses a lot of people. You start to solve it before that, and then you end up with some crazy answer because you forgot all about the 180. Solve that equation. Somebody, while some of them solving that equation, tell me what the equation would be on this second problem.
14x plus 70 plus 20x plus 8 equals 20.
So this plus this equals the whole thing, which we know is 180. solve both those. You're going to tell me what x is here in a second. On the first one and on the second one. Anybody get x on the first one yet? -4? Yes, no, maybe?
Yeah.
-4? Ricky, you agree with that? How about the second one? Anybody get x on the second one yet? Too early on that one? 3? Anybody agree with Raven yet? Colin does? 3? Going once, going twice. 3?
Can you give us a little bit more time to work it out?
Yep. I usually try to get at least 3 or 4 people to agree on it before I write it down. Unless their name's John. If he solved it. Come on, you can solve those. Try. Is that never doing nothing? Is it gonna work? You gotta at least try. Even if you don't know how to do it. Act like you know how to do it.
She said
Try. That's all I can ask you. Try.
Did she say 3?
She said 3.
Yeah, that's right.
3? 3's what we're going with? Yes, no, maybe?
Yep.
Yes.
Is that our answer for this one? No, what do we got to do with that? Plug it in. You're going to come back up here to this expression, and you're going to plug it in. -16 times -4 plus 13. What's -16 times -4? 64, positive 64. 64 plus 13, 70 what?
7.
Now, instead of writing out the angles this time, I'm just going to write our answers this way. 77 degrees, and circle it, instead of writing measure of angle, whatever, to make it a little quicker, a little simpler. That's fine. How would we find the other angle? You could just subtract it from 180. That might be easiest this time, right? What's 180 minus 77? What is it? 123. Right. You see Michael over here. You guys are going to have me move Michael to the back so I can't hear him. Because I'm going to write
Yeah, it's 103.
103.
My bad.
He doesn't want to grab his calculator there. That annoys me to no end when he's got a calculator sitting right there on his desk and he's going to subtract it in his head instead of using his calculator to try to figure it out. So this angle's 77, this angle's 103. Only takes about 5 extra seconds. Michael, grab that calculator.
I didn't multiply it wrong.
We'll plug in 3 over here. What's 14 times 3? 42 plus 70. Everybody agree with Raven?
Yeah.
That's one of our answers. How are we going to find the other angle? Subtract 180 minus that 112. What do you get? Everybody agree with Raven on that one? Michael's going to quit answering questions now because now he's got to grab his calculator. That's a good thing. Because I see it all the time on tests.
Yes.
Somebody does 77, gets that answer right, and they put down 113 or something here because they subtract it in their head instead of taking 5 seconds and grabbing their calculator and subtracting those two. Everybody got all that? What's these little boxes tell us? 90 degrees. Same kind of setup on these two problems. So we're going to write down both equations real quick. These two angles added together should equal how much? 90. Tell me the equation on this first one.
15x minus 43 plus 8x plus 8.
equals 90 degrees this time because adds up to be that right angle. That's our first equation on problem 29. Tell me the equation on problem 30.
10x plus 21 plus 13.
Write those down on your papers. I'll give you a minute or two. We're going to figure out what x is. Get them both already, John? No? Got it written down? Write down the first one. We're going to go through it real quick. You ready, John? We got 15x and 8x are like terms, right? 15x and 8x. How many x do you get? Write that down. 23x. John, go ahead and get that out while you're typical practice to get rid of it. Then we got a negative 43 and a positive 18. So if you owe me $43, you got 18 in your pocket, you know I'm not letting you walk out the door with that $18. That's coming to me, right? So how much you still owe me? 43 minus 18, right? I'm getting a bigger calculator, so the big old fingers you got won't hit the wrong button. It's not free. 25. So is it a positive 25 or a negative 25? Say positive, you still owe me $25. So we got 23x minus 25, what's still on the other side of the sum? You remember, right? Next thing we do, add 25 to both sides. So put a plus 25 right below there, plus 25 right below there. Draw a line in between, line where that blue line is, the regular part, that's right. Here. Look at that. These cancel out, right? 25s cancel out. What'd you get on X on the first one? 5. Everybody agree with that? Same idea here, and I'm going to move extremely quickly this time. I'm going to plug in that 5. Does anybody know what 15 times 5 is off the top of their head? So don't plug in there if you don't know it. Let's go down here. What's 8 times 5? That's a little easier, isn't it? Plug in where it's easy. Make things easy on yourself, Aiden. All right? Don't make it harder than it's got to be. What's 40 plus 18? So one of our angles is 58 degrees. What's the easiest way to find the other angle? We already know it's not plugging in there because we know what 15 times 5 was. What is it? 32. Make sure you write down both those answers, 58 and 32 degrees. Let's measure those two angles in that picture. Anybody get the second one? What's X? 3. Plug in. These are both pretty easy to plug in. What's 13 times 3? 39 degrees. That's one of our angles. That's this angle right here, 39 degrees. What's 10 times 3? 30 plus 21? 51 degrees. Make sure you write down both those. Huh? Nope, one more. Everybody got that? Ah, I went the wrong. No, I didn't. It went the right way. Somebody read this to me up here, this first sentence.
Ray BD bisects angle ABC.
Ray BD bisects angle ABC. If it bisects it, what's it tell us about it? These two parts are congruent to each other, so we could mark them congruent. This one we're going to set up different, Jesse. Because do we know this plus this equals the whole thing? Yes. The bad thing is, do we know the whole thing? What do we know about these two parts? They're congruent. They're equal. So what equation can I set up?
3x plus 6 equals.
So you've got to be able to pick out these different problems. This time we're going to say this equals that. Solve that. Find out what X is there. Write that down and solve it. What's 3x minus 3x? They cancel out, right? What's left on that left side? 6 equals, what's 7x minus 3x? 7 minus 3 equals 4x, so 4x, still minus 18 out there, right? Next thing we're going to do, we got all the x's on the right, so we're going to move everything else to the left. How are we going to move that 18 over to the left? If we're subtracting it, what's the opposite? So we're going to add 18 on both sides. Nah, don't change that one. Write it down below it, right? So minus 18 on both sides. Oh, I'm sorry, it should be plus 18 on both sides. I apologize. Confused me because you changed that sign. Maybe I'll confuse. Draw a line underneath there. What's 6 plus 18? 24 equals, the other side, what have we still got? 4x, right? Divide both sides by what? Divide those, what's with the x? 4. So what do we divide both sides by? 4. What's 24 divided by 4? 6. So x equals what? Anybody else get that? Tell me the two angles real quick. What's this angle? 24 degrees. Somebody said, everybody agree with that? What's this angle? What? You just told me 24. Oh, they're the same. So one angle's 24, the other angle's 24. How much is the big angle? They ask you for all three angles this time, right?
Yep.
Make sure you got all three of those answers on there. Set that paper off to the side. You're going to do something with it here in a minute. But we are going to do this. Grab a clean sheet of paper. You're going to write this down. Special pairs of angles. I'm going to say it like 5 times right now. Special pairs. These are your notes. Special pairs of angles. Special pairs of angles. Caleb. Special pairs of angles. Colin. Special pairs of angles. Everybody got it in their head. Joe. Special pairs of angles. That's your title for the notes today. We're going to learn 5 different special pairs of angles. One of them I forgot on here, and it's adjacent angles. You probably never ever see me write out the word angles again. I always use the symbol. 'Cause I'm lazy. Complementary angles, supplementary angles, vertical angles, linear pairs, and adjacent angles. All you need to write down off this page is special pairs of angles. Next page. Adjacent angles. Write this down for adjacent angles. Again, Abigail knows whose notes are these. Joe, will you hand that paper to her? These are your notes. Write them so that you can understand them. You don't have to write word for word up here. If I come to this word and, do I have to write out A and D? Maybe put the and symbol or something in there. Make it shorter on yourself. I don't care. As long as you can understand it. All right, because I'm annoyed by that music already. Adjacent angles. Does anybody know what the word adjacent means?
Isn't that like those?
Hook to. Next to. Whose room is adjacent to mine? Mr. Alexander's room. Right? Not Mr. Slam's room. Not Mr. Boggs' room. Mr. Alexander's is adjacent. Adjacent angles. So if I look at this picture right here, name me 2 adjacent angles. 2 and 3. Does everybody agree with that? Give me another pair of adjacent angles. 1 and 4 I heard. Are there others other than those I just wrote down? Yeah. This one, we don't use it a whole lot. Because did that tell us anything mathematical about those 2 angles? When I say my room's adjacent to Mr. Alexander's, does that really tell us anything about the room? If I say my room is congruent to Mr. Alexander's, does that tell us something? Yeah. So that's adjacent angles. We don't use it a whole lot. They share a vertex and they share a side. Complementary. Anybody ever heard of complementary angles? If not, what's this box tell us? Right angle. Complementary angles. 2 angles that add up to 90 degrees. If you wrote that down right now, that's all you really need to write on this page. 2 angles that add up to 90 degrees. Complementary angles. 2 angles. Not 3 angles, not 4 angles, not 6 angles. 2 angles that add up to 90 degrees. Were we just dealing with complementary angles there a few minutes ago? Yeah, it was in like problem 29 and problem 30 or something, wasn't it? Those 2 angles had to add up to 90 degrees. This right here is red. Angle 1 is complementary to angle 2. A big part of geometry is learning how to read those shortened forms. Because I'm very, very lazy and I'm going to compress everything as much as I possibly can. Does anybody know the other names of angles that add up to something? Got complementary angles, 2 angles that add up to 90. What's the next one? Nobody knows? Put it up here then. Supplementary angles. Supplementary angles are 2 angles that add up to 180. Supplementary angles, 2 angles that add up to 180. Camden didn't have a clue what that was. We look at this picture. Yes.
Yeah.
Yes. Sure. Hey,
That's what I'm saying.
grab your stuff, take your stuff with you. Make sure you stop back and get the assignment during intervention or something, all right? Office. On this, supplementary angles. Supplementary angles, two angles that add up to 180. In this picture, give me two angles that add up to 180. 1 and 2, do they make a straight angle together? So they're supplementary. A linear pair. All linear pairs make a line. So if two angles are a linear pair, then they're also supplementary. Just because two angles are supplementary, does that mean they have to be a linear pair? No, they could just be two angles. One more before you go anywhere. Don't move. Vertical angles. Watch closely. Vertical angles, very, very important. Go ahead and go ahead. If I take two lines and make them intersect, it's four angles formed. Guess what's always true about these two angles right here? They're always congruent. And that's what's true about vertical angles. These two angles, no matter how I do this, John, I cross them some different way. Guess what's true about these two angles? They're congruent. I take it apart, I do it again. Guess what's true about these two angles? They're congruent. Those are vertical angles. Don't go anywhere. The assignment. Oh yeah, before you go anywhere, daggone it, I forgot to tell Aiden. That's the assignment. I'll try to put it on Moodle. Make sure your stuff gets back in the box, and you're going to lay your homework right there on that. Make sure all the stuff gets back in the boxes. Lay the homework right there.
Wait, the one we did in class?
Adjacent angles. Adjacent angles are angles that share a common vertex and a common side between them. Again, as you write down these notes, write down what's helpful to you. All right? And make sure you can read it. Right, Thor? Make sure you can read it. Make sure it makes sense to you. They're your notes. With adjacent angles. Adjacent angles, not real important. You need to know what they are. But in that definition right there, does it tell you anything mathematical? If we're talking about the school here, whose room is adjacent to mine? Mr. Alexander's room. We share a wall. Alright? In this picture, angle something and angle something else are adjacent. Give me one angle in that picture. One. Give me another angle that's adjacent to it, an angle that shares a side, a wall with it. Two. Those are adjacent angles. Doesn't tell us anything about the angles, just tells us that they're next to each other. Alright? So adjacent, we don't use a whole lot, but sometimes they'll say something about adjacent, so we need to know that. Next. Complementary angles. Write this down. Complementary angles. Have you ever heard complementary before? What's the other word that goes along with complementary? Anybody remember that? Supplementary. Complementary and supplementary. Supplementary is going to be on the next slide. Next week, number one, we'll have a test over chapter 1 next week. We'll probably also have a definitions test next week. Guess what one of the terms on there is going to be? Complementary angles. This is what you're going to write. Even though this definition, notice this definition, I probably stole it from somebody else because it looks all neat and everything. I wouldn't ever write out that definition. My definition, two angles that add up to 90 degrees. Now notice the part that Kenneth forgot. You forget that on the definitions test, it's going to be wrong. How many angles? Not 3, not 4, not 5, not 6. 2.
Can we put the big giant 2?
That's 2 angles that add up to 90 degrees. That's fine. If we read this, again, my laziness, I'm going to shorten things up as much as I possibly can. Angle 1 is complementary to angle 2. So what's that tell us about angle 1 and angle 2?
They add up to 90 degrees.
They add up to 90 degrees. Complementary angles. Write this down. I'll give you a second. Supplementary angles and linear pairs. Both definitions are in there. Supplementary, same idea with supplementary. When I ask you the definition of supplementary, what's the key part you're going to make sure you put in the definition? 2 angles that add up to 180. If you just wrote that, 2 angles that add to 180, spectacular. A linear pair. Music's going to come back on. That's going to annoy me. Sorry, I'll get back. A linear pair. If I'm looking at this picture, first of all, tell me 2 angles that are supplementary to each other in this picture. 1 and 2. When I look at those 2, well, they add up to equal 180 because they add up to equal that straight angle. We just got done doing some problems like that, right? That's what a lot of your homework's going to be, stuff like that all over again. A linear pair are 2 angles that together make a line. That's all linear pair is, 2 angles that together make a line. All linear pairs will be supplementary angles. Are all supplementary angles linear pairs? George is going to come back to our world here for a second, and he's going to watch this. This angle's 20 degrees. That angle's 160 degrees. Are they supplementary to each other? Yeah, because they add up to be 180. So they are supplementary. Are they a linear pair?
No.
Together, do they make a line? No, they're completely separate from each other. So all linear pairs are supplementary, but not all supplementary angles are linear pairs. Last one. I take these two lines here, I make them intersect. Special angles are formed. First of all, how many angles are formed? 4. Alright? Guess what's always true about this angle and this angle? They're always the same. Even if I take them apart and I do it again, Noah, guess what's true about these 2? They're the same. I take them apart, I do it again, guess what's true about these 2? They're the same. No matter what, you have 2 lines that cross anywhere in our world. Now if you go to Kevin's world, you got 5 or 6 dimensions. In our world, we only have 3 dimensions, Kevin.
That's not hard on me.
But you go to Kevin's world, and you have 5 or 6 dimensions, and maybe it's something different. But in our world, guess what's always true about these 2 angles? They're always the same. Does anybody know what those angles are called?
Perpendicular lines?
That they could be, but that's not what the angles are called. Vertical angles. Write that down. Of all the stuff that we covered today, supplementary and vertical, probably the 2 most important things. Vertical angles are a key part of all geometry. you can't pick out vertical angles by the end of the year, you can't tell me stuff about vertical angles by the end of the year, then we'll probably spend a couple of years together. I know, Thor, that doesn't sound good, does it? Believe me, I don't like it any more than you.
I'm cool on taking a class, but it's one time is enough.
I never have understood. My family didn't even like being around me. I don't know why students would want to be around me for more than a year.
Not that I don't like you, I just don't want to be class with you. So how do you act up to one time and enjoy it?
Huh?
Why do you add music to it if you don't want it?
I don't like the music.
Why do you add it if you don't want it? If it gets
Something different.
It's random.
I actually pick it randomly. Sometimes I have students pick it, but then when I've done that in the past, I've had students that were stupid, pick something stupid, and then I had to erase
They
it.
play some rap music.
So vertical angles in this picture. In this picture, name me 2 vertical angles. Name me 1 angle in this picture. 2. We pick angle 2. Name me another angle that's vertical to that one. 4. The ones that are across from each other. So we said 1 and 4. That's like me and Mr. Alexander's room. All right? Hooked together side by side, not vertical. Be like me and Mr. Slam's room. All right? Across from each other. Those are congruent to each other. So angle 2 is congruent to angle 4. What's the other pair of vertical angles?
1 and 3.
Angle 1 is congruent to angle 3. So if I put this in here, I told you angle 1 right there was 70 degrees. Tell me something else you know in that picture.
3 is 3.
3 is 70 degrees. Is that all you know? What else do you know? What do we know about 1 and 2? They're supplementary, aren't they? So what is angle 2? Be careful. What would you have to do to find angle 2? Subtract it from 180 and you get what? 110. Good. Now what's angle 4? So every time if I draw a picture, it's got 2 lines in it. If my pen would draw. If I draw a picture, it's got 2 lines in it, and I give you this angle right here. How many of these other 3 angles should you be able to find? All 3 of them, every single time. We just did that. What's always true about vertical angles? They're always congruent to each other. They always have the same measure. Remember, congruent means same measure, right? One of the key theorems that we're going to have this year. Shortest theorem in the book, and you'll never see me write out like that again. Shortest theorem in geometry. Vertical angles are congruent. It's one of our theorems. Vertical angles are congruent, always. That's your assignment. We got 4 minutes. If you hurry up and write it down, I'll start working problems. Unless you don't want me to, which I have no objection to going back and sitting on my fat behind on my chair back here. George has already got out a piece of paper. He wants to say, yeah, I don't want you to do my homework. Somebody read problem 1 to me. Page 52. Everybody got it written down?
What is the difference between adjacent angle and vertical?
Difference between adjacent angles and vertical angles. Number 1. Difference between adjacent angles and vertical angles. What are adjacent angles?
They're like they
Hooked to each other. Vertical angles are cross from each other. That's what you write. Vertical angles hook to each other, adjacent angles hook to each other, vertical angles cross from each other. Everybody got it now? There? Didn't hear no complaints? Number 2, what's number 2 say? I didn't put it up here, I thought I put it up here.
Which one does not belong with the other three?
Which one doesn't belong with the other 3? Look at that.
And the reason.
Looks like the third one. Looks like the third one there. Why? In that third picture, those 2 angles are what to each other? And S word. Supplementary. All the rest of them look like they are complementary. So the third picture. Number 3, name a pair of adjacent angles in this picture. We want a pair of adjacent angles. Give me a pair of angles in this picture. Let me get my pen color back here. Come on.
34. N and P.
Can't name an angle with N and P. Angle, name this angle right here for me. Angle FGE. We want an angle that's adjacent to that. FGH. That's all you got to do, name those 2 angles. Are there other angles that you could put for that answer? Next one says adjacent supplementary angles. So not only do you want them to be hooked together, but you want them to add up to how much?
180.
180. Are we going to get these 2 up here to ever add up to 180? So forget that picture for now. We're going to be on this one down here. Pick an angle down there. KJL, I thought I heard. Angle KJL, that's this angle. Does anybody see an angle along with that one that supplementary adds up to 180? LJN. Don't worry about that other ray in there. That's what you're going to do on some of those. And some of them, they're actually going to ask you to set up equations and stuff. Have a good weekend.